Welcome back to our NSEA astronomy practice session. In this video, we will solve 10 important multiple-choice questions on the sun and stars. These questions will strengthen your conceptual clarity for the National Standard Examination in Astronomy. After every question, I will reveal the correct answer and briefly explain the concept. Let's begin. Question 1. If all nuclear reactions in the sun now were to suddenly stop forever, then A. Distances between planets and sun would decrease. B. Angular momentum of planets would increase. C. Inner planets will be engulfed by the sun. D. Speed of rotation of the sun would increase. Correct answer is D. Speed of rotation of the sun would increase. When fusion stops, gravity collapses the sun, reducing its radius. Conservation of angular momentum increases its rotation speed. Solar mass remains same initially, so planetary orbits don't change immediately. Question 2. As observed from a place in Australia, the pole star, A, appears in the southern direction. B, appears at about 30 degrees above the horizon. C, much brighter than that seen from India. D, can never be seen. Correct answer is D, can never be seen. Polaris is a northern sky star and lies below the horizon when viewed from Australia in the southern hemisphere, making it permanently invisible from those latitudes. Question 3. For a binary star system with two identical stars, A, the stars are always at the same distance from each other. B, Doppler effects of both cancel out each other, resulting in a normal spectrum. C, the inclination of the circular orbit with respect to the observer does not affect the observed orbital parameters. D, Kepler's law for orbital periods is always applicable. Correct answer is D. Kepler's law for orbital periods is always applicable. Kepler's third law applies to all bound orbital systems, including equal mass binary stars. Doppler shifts and observed motion still depend on orbital inclination and viewing angle. If you are finding the video helpful, please like and subscribe. Question 4. Which of the following terms refer to a variable star? A, white dwarf. B, RR Lyrae. C, black hole. D, eclipsing binary. Correct answer is B and D. RR Lyrae stars are intrinsic pulsating variables, while eclipsing binaries show periodic brightness variation when one star blocks the other. Both display measurable luminosity changes. While some white dwarfs can be part of variable systems, like a cataclysmic variable, a white dwarf itself is not a variable star. Question 5. Cepheid variable stars have fluctuating masses. Some astronomers attempt to use these stars to A, compare to dying stars to determine time of stellar death. B, mark distances throughout a galaxy. C, map a solar system. D, both B and C. Correct answer is B, mark distances throughout a galaxy. Cepheids follow a precise period-luminosity relation, making them standard candles to measure distances to star clusters and galaxies. They are not used to map solar systems. Question 6. Spectroscopic analysis of light from stars gives us information about A, the abundance of elements in stars, B, parallax of stars, C, the radial velocity of stars, D, proper motion of stars. Correct answer is A and C. Spectral lines primarily reveal chemical composition and also radial velocity through Doppler shift. Parallax and proper motion are measured by astrometry, not spectroscopy. Question 7. The formation of an iron core in a massive star leads to A, stable equilibrium for billions of years. B, immediate expansion into a red giant. C, gravitational collapse and a supernova. D, complete evaporation of the star. Correct answer is C. Fusion releases energy only up to iron. Fusing iron requires energy, so the star can no longer produce energy to support itself, and the core collapses, triggering a supernova explosion. Question 8. Period-luminosity relation states that Cepheids with longer periods are A. Hotter and smaller, B. Fainter in luminosity, C. Identical in brightness, brighter and more luminous. Correct answer is D. Longer period implies higher luminosity, as discovered by Henrietta Leavitt in 1912 while making observations of Cepheid variable stars in the Magellanic Clouds. Question 9. The balance between the inward pull of gravity to compress the stellar material and the outward pressure from hot gases and radiation to prevent collapse inside a star is called A. Radiative equilibrium, B. Hydrostatic equilibrium, C. Thermal equilibrium, D. Rotational stability. Correct answer is B. Question 10. The amount of light energy a star emits per unit time is called A. Brightness, B. Magnitude, C. Luminosity, D. Flux. Correct answer is C. Luminosity is the intrinsic energy output of a star per second. Brightness and flux depend on distance, and magnitude is a logarithmic scale of brightness, not intrinsic energy output. Great job! You have completed 10 important MCQs on the sun and stars for NSEA preparation. Keep practicing consistently to build a strong foundation in astronomy. If you want more mock tests, PYQs, and concept explainers, don't forget to like, share, and subscribe. Until next time, keep exploring the universe.